In this course, we are going to create an inventory management system with .NET 10. The technologies that we're going to use to create the application are Blazor with static server-side rendering and Blazor with interactive server-side rendering. Also, we're going to use Entity Framework Core, SQL Server, and ASP.NET Core Identity to secure the application. The architecture that we're going to use is the Clean architecture, also called the Onion architecture. You will need to know a little bit C# and a little bit SQL before you can take this course. But the rest of the technology will be covered in this course while you are learning to create the application. This course is focused on practice and creating the project. There won't be a whole section of concepts and series, but you're going to learn a lot of these concepts while you are creating the application. So if you have learned all of these technologies in the past, but you need a project to practice and catch up with the latest changes in .NET 10, then this is a perfect course for you. Especially, I will take you through the process of implementing the application with Clean architecture. If you haven't learned Blazor, Entity Framework Core, or ASP.NET Core Identity, don't worry about it. All of these concepts will be covered in this course while you are creating the application with me. Let's take a look at the application that we are going to create. This is the inventory management system. We will be able to manage inventories, manage products, purchase inventories, produce products, and selling product. We're also able to run inventory report and product report as well. On top of all of this, we're using ASP.NET Core Identity for authentication and authorization. For example, if I log in as an inventory manager, I'm able to manage inventories as well as managing products. I can add product or I can edit an existing product. We can also delete an inventory or delete a product. In addition to all of these CRUD operations, we're able to search inventories or search product with this search bar. The technology we're using for managing inventories is Blazor static server-side rendering. And then for managing products, as well as purchase inventories, produce products, sell products, because it's slightly more complicated, we're using Blazor with interactive server-side rendering. This is when I try to log in with Inventory Manager. Therefore, I can manage inventories and products, but I cannot purchase. For example, if I go to purchase, I'm not able to access. Or produce, I cannot produce products, and I cannot sell products. But I'm able to access inventory reports or product reports because everyone is allowed to access them. So this is the inventory report and this is the product report. I have different filters for searching different transactions in each report. Now, if I log in as a salesperson, then I won't be able to access inventories or products, but I should be able to sell product. However, I'm not able to purchase or produce. And there are different roles in the application. We have sales, we have the administrators, we have production management, we have purchasers, and we have inventory managers. If I log in as administrators, I'm able to access a hidden page, which is used for managed users. I can see a list of users, I can manage existing users, and specify the department that it belongs to, which gives access to different sections in the application. Last but not least, I want to show you that we can print a report by clicking on this print button, and you can print to your printer or you can print to PDF. For example, if I just print to PDF, I can specify the printout file name, and then I can see the PDF print out beautifully. As you can see, we have a lot to cover. So without further ado, let's jump into the course and study together. In this first section, we're going to talk about how Blazor works in general. But in order to know that, first of all, we need to know how a traditional web application works so that we can compare that with how Blazor works. Whether it's a traditional web application or a Blazor web application, we always have a user to interact with a browser. And when the user does anything in the browser will try to contact the server in order to get information, because browser is an application that is used to contact remote servers to retrieve HTML in order to display information on the browser. So therefore, a HTTP request is sent to the remote server. Then the remote server will process the request. The processing is somewhat complicated
but it all boils down to a final function. The function will take the HTTP request, process the request, and generate HTTP response. What is in the HTTP response? It is typically HTML that is generated from this function and sent back through the HTTP response to the browser. The browser, when it receives the HTTP response, it knows how to handle it. Usually, it just renders the HTML inside the browser, and then the user sees the result that he or she expects. Then the user interacts with the browser, and when that happens, another HTTP request is sent to the remote server. Again, maybe the same function, maybe a different function, process the request and construct the final HTML, sends that back within the HTTP response to the browser. And then the browser renders that HTML in the browser. Then the user sees the HTML. This is how traditional web application works. There's one thing I want to emphasize here, which is a traditional web application, when it comes to the server side, it is a stateless application, which means that every time a new response comes, the object that contains function is constructed. And once the response is returned back to the browser, the object that contains the function is deconstructed, disposed. So it's out of the memory. And then the next one comes, a new object is constructed. And that new object contains the function that is needed for processing the HTTP request. So traditional web application is a stateless application. That's the second thing I would like you to understand. So there are two things we talked about. The first thing is traditional web application is based on the request and response workflow. And the second thing is that traditional web application is stateless web application. It doesn't remember the state of the application. Everything has to be stored within the HTTP request and HTTP response if you want to maintain any state. All right, that's everything I want to cover in this video. I will see you in the next one.
In this video, let's talk about achieving interactivity with JavaScript. So in the previous video, we'll talk about the workflow of traditional web application, which is based on the request and response model. But this type of working model works very well for static page renderings. For example, for a website, you want to see a blog and you send an HTTP request, the server processes the request and just returns the whole article back to the user. And then the user clicks on the next blog article. Again, HTTP request sent to the server. The server knows which article the user wants to see and returns back as HTML in the HTTP response. So you can see that each time the user wants to see the next article, there's a full page refresh. A request sent to the server returns back as HTML response, and that renders as the full page. And in between, the user is just waiting. And once the HTTP response comes back, the whole page is refreshed. So that works very well for blog post type of applications. However, if you have some type of interactivity in the web page, then this type of request and response model wouldn't work very well. For example, if in your web application, you have a search bar where user can input the search criteria and click on the search button, and then some kind of result needs to be rendered below this search bar. And each time the user enters a new information, click on the search, then this area needs to be re-rendered. If we are taking the request and response approach, each time the user clicks on the search, the HTTP request is sent to the server and the HTML for the whole page comes back. That means the entire page needs to be rendered. However, in reality, this part that is highlighted with orange color, this part needs to be refreshed. So all of the other parts on the page can stay, only this part needs to be re-rendered. And we are not able to achieve this with the traditional web application. So therefore, within traditional web application, in order to achieve this type of functionality, we need to add JavaScript. So with JavaScript, the application model becomes, so let me for now remove this, and let's focus on how this works. So basically, the user interacts with the document object model, which is DOM in the browser. And that interaction is going to be captured by JavaScript. You will have to write your own JavaScript file in order to handle this type of interaction. Okay, so interaction is captured by JavaScript, and then the JavaScript is contacting the server in order to
retrieve the information that is needed. Now on the server, there's another function that is needed for handling this type of request. And then a response comes back from the server to the JavaScript, usually in the format of JSON. So the JavaScript reads the JSON, which contains the data, and then the JavaScript modifies the DOM, and then the user sees the modified DOM. So the entire DOM is not reloaded, only partially patched. So let's go through this whole process again. When the user comes to the browser the first time, there has to be a HTTP request and HTTP response. So the page is rendered inside the DOM. Then when the user interacts with the search bar, that interaction, in that particularly, is the click event of the button is handled by the JavaScript. The JavaScript is then used that search criteria, go back to the server, and the server has a different function to process that request. Then it will return all of the data that is needed to display under the search bar. Once the JavaScript receives the result, it is responsible to patch the DOM. In this case, it needs to replace the area that is below the search bar with the data in different HTML elements. So that's the whole process, and that's how in traditional web application interactivity is achieved. It is achieved with JavaScript, and you as a developer will have to be able to write JavaScript, will have to be able to use JavaScript to call remote functions. Usually this is called Web API, and you have to be able to analyze the JSON, which contains the data, and you have to be able to patch the DOM. So that's the whole process of achieving interactivity with JavaScript in traditional web application. So knowing all of this will help you to understand how Blazor works, which we're going to cover in the next video. Okay, that's everything I want to talk about in this video. If you have any questions, please let me know. If not, I will see you in the next one.
In this video, let's learn about how Blazor static SSR works.
So in the previous two videos, we have learned about how traditional web application works. It's based on this request and response model. And then when interactivity is needed, then we use JavaScript. That's how traditional web application works. When it comes to how Blazor works, Blazor actually has different features that implements the same things as traditional applications. So therefore, there is something in Blazor that does the same thing as traditional application. It's based on request response model. Not completely, but almost completely.
And that is called Blazor static SSR. SSR stands for server-side rendering. Therefore, static SSR
stands for static server-side rendering. So you can sort of perceive the feature of this. So it's static and it's rendered from the server. So that's the same thing as traditional web application. It is also based on this request and response model. Each time the user needs something, it sends a request and comes back as HTTP response. There's a slight difference which I'm going to cover in a future video. However, you can sort of consider
Blazor's static server-side rendering
is based on the HTTP request and HTTP response model. And then here on the server side within Blazor, it's not just one function, it is a series of functions that process the request. And we're going to talk about that later. But for your understanding, you don't need to worry about how many functions are being used to handle the HTTP request. You can sort of still consider there is a function. So therefore,
Blazor's static server-side rendering works
very, very similar as traditional applications. It's based on the HTTP request and HTTP response model. And that's everything you need to know, and that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's talk about achieving interactivity with Signal channel. So in Blazor, we know that Blazor SSR, which is static server-side rendering, works the same way as traditional web application. But when traditional web application needs interactivity, it uses JavaScript. However, in Blazor, when it comes to achieving interactivity, Blazor has different approaches. The first approach is achieved by setting up a Signal channel from the browser to the server side. And this is called
interactive server-side rendering, or interactive SSR.
So let's borrow the diagram from this JavaScript interactivity, which is used in traditional application. Let's copy this and paste this over. And let me remove this line and this function here. All right. So when the user tries to go to a website, the first request and response will have to be there. You cannot get away from that. it is the first request and response is always full page load, right? There's no interactivity. There's just a request, goes to the server, processed, and the full HTML is rendered in the browser as DOM. After that, for achieving interactivity, Blazor framework, which is provided by Microsoft, it comes with a JavaScript file. This is not our own JavaScript file. It is a JavaScript file that is created by Microsoft, and that is called blazor.web.js. As I said, this is written by Microsoft. It's not written by the developer. And this special blazor.web.js file is used to set up a Signal channel, which is a WebSocket channel. It's sort of like you're using a chat app that has a P2P connection with the person who you want to chat with. So this one set up a Signal channel, and this channel is connected from the browser to the server. And after this is set up, a page representation is created, which represents this DOM. And after that, all of the user interactivity is achieved by sending messages back and forth between the browser and this in-memory representation of the page. So there's no more HTTP request and HTTP response. Notice that everything is still processed inside the server, and then that the data comes back to the browser and then handled by blazor.web.js, and then blazor.web.js is able to smartly patch the DOM.
That's how interactive SSR is achieved.
So you can see that we no longer need to write JavaScript, right? Because it's handled all on the server side, you can still write C#. Your C# code is written on the server side, and the blazor.web.js is responsible to communicate with your C# code through this Signal channel, and then it is also responsible to patch the DOM. So comparing this picture with this picture, it's very similar, but it's different. Here, the JavaScript is responsible to call the remote web API. You will have to write the web API, you will have to write the JavaScript, and you have to analyze the JavaScript. You are responsible to patch the DOM. Here in Blazor server-side interactivity, first of all, the JavaScript is not written by you. You are responsible to write the C#, which is running on the server. And this communication is also handled by this blazor.web.js file. And it is also this file that is used to smartly patch the DOM. It doesn't update the whole DOM. It identifies the difference between before and after and only renders the differences on the DOM. So that's how interactivity is achieved
with interactive SSR,
which is based on the Signal channel. And Signal channel is a WebSocket channel.
The interactive SSR seems to be
pretty complicated, but you have to know that you are not doing anything special. Your only responsibility is to write C# on the server side and use the C# to compose the DOM, which is very simple.
Once you start creating application with interactive SSR,
you will find that it's actually very simple and one of the fastest way to create web applications. And that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one.
In the previous video, we talked about the interactive server-side rendering,
which is accomplished by using a WebSocket channel, and we call that Signal channel. There's actually another way to achieve interactivity, and that is called
interactive WebAssembly.
So in this video, let's try to learn about achieving interactivity with WebAssembly. So comparing
interactive WebAssembly with
the JavaScript interactivity in traditional web application, it is actually very, very similar. Let's copy this and paste this over. Just borrow the diagram. And let's remove these lines and this function. So you can see that this is the traditional web application. And here, in order to run any functionalities in the browser, we have to use JavaScript. But JavaScript is not the only thing that can be executed within the browser. There is another type of code that can be executed within the browser, and it's actually natively supported by most of the modern browsers, and that is called WebAssembly. So here, instead of using JavaScript, we can use WebAssembly. I'm not saying that we are writing WebAssembly. We are actually writing C#. And Microsoft, or the Blazor framework, is responsible to translate our C# code into WebAssembly. There are different ways to do this, but in the end, you will have your C# code that running inside the browser. Okay, so here, although I say WebAssembly, but actually you have to consider that your C# code is running directly inside the browser. So let's go through this whole process. The user tries to access the web application. And again, the first request and response, you cannot get away from that. This is going to be a full load from the server, right? The full page is loaded into the DOM and the user sees the HTML page.
And it's not just the HTML that is downloaded. The WebAssembly that contains the .NET runtime as well as your custom C# code are downloaded as well.
Now, when there's interactivity, that interactivity is handled by your C# code as WebAssembly. And that, if it requires data from the remote server, that is the same thing as the JavaScript interactivity, right? You will need to contact remote web API. This remote web API may reside in the same server. It may also reside in a different server. Right, let's just use the same server as an example. Your C# code calls the remote web API, and then this remote web API returns data back, usually in JSON format. The same thing as JavaScript. The difference is that before you're handling this web API with JavaScript. Here, you're handling the web API with your C# code. So if you're a C# developer, then you just need to learn C#, right? You learn C# so that your code runs on the server side. You learn C# to create web API. And you learn C# in order to support interactivities in the browser. So C# is able to help you to achieve full stack development. You don't have to learn JavaScript. Well, I would say more than 90% of my web development work no longer involves JavaScript, probably even higher than that, maybe 95%. You probably still have to learn a little bit of JavaScript here and there, but it's nothing intensive comparing with Angular, React, Vue.js, or even jQuery. So this is how WebAssembly works. Let me explain again where this WebAssembly comes. Right? So the first time, which triggers the first request and response, that WebAssembly comes within that response. Right? WebAssembly is downloaded from the HTTP response and placed inside the browser and start executing. Once it starts executing, the later navigations, the later user interactivity is all handled by WebAssembly. And if the WebAssembly needs data from remote server, then it needs to call a web API that resides in the same server or in a different server. And then data comes back as JSON, and WebAssembly is used to patch the DOM.
In this video, let's try to create our first Blazor project in order to show you what is the project structure for Blazor application. So I'm using Visual Studio 2022 Preview Edition with .NET 10 Preview 7 installed. And let's try to click on this Create a New Project button. And then if we come over here to this drop-down list and select Blazor, we'll be able to filter out the other ones. And we can see that we have 3 templates available. And for Blazor application, the main template is the Blazor web application template. And we're going to select this one and click on the next button. And here, I want to call my solution IMS, which stands for Inventory Management System. And then here for project name, I'm going to call it ims.web app. And now I'm going to click on the next button. And now we're looking at this complicated screen, relatively complicated. And of course, we're going to select .NET 10. And as I mentioned, I'm having Preview 7 installed. And as the preview version progresses, I'm going to upgrade. And for authentication type, we're going to select none at this moment because later we're going to add authentication separately. And we're going to keep this application runs under HTTPS instead of HTTP. And for interactive render mode, this is the place that people may get a little bit confused because if we select different options here, you can see that it triggers another drop-down list, which is interactive location. But since we are just starting, we want to learn how Blazor application runs corresponding to a traditional web application. And the feature that corresponds to a traditional web application is static server-side rendering. Static server-side rendering means there's no interactivity. Therefore, in order to let the template configure the application runs as a static SSR, we're going to select none for interactivity render mode, right? Interactive render mode. So there's no interactivity at all. Therefore, we don't have to even select the interactivity location, which is the second drop-down list, right? So that second drop-down list is hidden now. Now, we are going to include some sample pages in order to learn fast. And now we're ready to click on the Create button. Okay, so we have our first Blazor application created, and let's go to program.cs file. A program.cs file is a basic C# file. So if you have learned C# before, I trust you have learned, because that's one of the prerequisites of taking this course. So you must have already seen a program.cs file. The file runs line by line. And what's special about this program.cs file is that there is a app.run method runs at the last. And this actually runs in a loop. And when it runs in a loop, it listens to the incoming HTTP request. When an HTTP request comes into the application, it's going to pick up by the application, and then it's going to go through all of these lines, right, that is after line 8. It's going to go through this. And each one of them performs its own functionality and take care of different things. But when it comes to the last line here, map Blazor component, it's going to map the HTTP request to a particular component. So if we look at our diagram over here, for traditional web application, we have this function here that takes care of the HTTP request and then generate the HTTP request. But because Blazor is a single page application framework that is based on components, therefore we're no longer just map a request to a function, whereas we're mapping a request to a component over here. Although that when I talk about the Blazor static server-side rendering, I was using a function here, but at that time I said this is like a function, but it's not entirely the same. And we're going to talk about that later. For now, as long as you can see that this function or method actually maps the HTTP request to the app component, which is basically the root component. And where's the root component? It's under the components folder, and you can see it is right here, app.razor. So we call this as a razor component, and this is at the app.razor is actually a special component. It's called the root component, R-O-O-T, root. So the root component takes care of all of the incoming HTTP requests. And if you look at the body element here, we have a router component right here. So when this app component is being executed, this router component will be executed too. And this router component is responsible to map the incoming HTTP request to a component, which is most likely a component that you write as a developer. So it's going to map it to that component, to your component according to that URL. And when that happens, let's go inside the router component. You can see that here's the name of router here. So when the incoming request comes into the router component, once the router component finds your custom component, it's going to then apply the main layout to your custom components. And so far we have some sample pages. So for example, we have a home page, which is very simple HTML, right? But it doesn't have the HTML tag. It doesn't have any layout information. So let's suppose that the incoming URL is /, which corresponds to the root path. So what happens is that the map Blazor component method is going to map it to the app component. And then the router component will map the URL to the home component because it corresponds to the location. And then the router component tries to apply the main layout. So where is the main layout? We go to the layout folder. We have a main layout.razor. And over here, we can see that we have all of the layout related to HTML tags. And then we have a body placeholder. So your component, in this case, is the home component. So this HTML is going to replace the add body placeholder. And then you will have a more complete HTML, and this more complete HTML is then going to replace the router component here. And then finally you have a complete HTML that has a head element, a body element. So now you can see the entire project structure, right? So the program.cs file is the first file that is going to be hit by the HTTP request. And the second one is the app component. And after that is the router component. And after that, the main layout is applied. So program.cs is the first one. App.razor is the second one. The router component is the third one. And the main layout is the fourth one. After the main layout is applied, we have a complete HTML that is ready to be rendered back. So that corresponds to this. So you can see that even with static server-side rendering, we're no longer using just one function that takes care of the entire request. We're using a nested component, and that nested components generate the final HTML, return that as part of the HTTP response back to the browser. I'm creating this video to report a breaking change in release candidate 1. And note that this video is created after I created about the first 36 lessons already. So if this breaking change affects you, then please make sure that you watch and go ahead and fix that. Today is September 18th, 2025. I just updated my Visual Studio from the Community Edition 2022 to Community Edition 2026. I think it's just came out. So after the update, what I got from the download is a .NET 10 release candidate 1. So previously I've been working on this course based on preview version 7. So now I have release candidate 1. I have something that is broken in program.cs file. You can see that this parameter name has changed. So if we look at these signatures here, the second one contains a Boolean parameter here. It's called a different name. So we need to fix this. I'm going to do a autocomplete here so I get this name, create scope for status code pages. Because this course is created by using preview 7 until probably around lesson 36. So if you download the code in GitHub that corresponds to those early versions, you probably have the same problem that I just encountered. So please come over here and fix this by changing those errors to status code pages. This would make it work. So this is release candidate. I'm almost sure that they won't change names after release candidate 1. But if they do, then it will update you. In this video, let's learn about enhanced navigation. Why do we need to talk about enhanced navigation? Because as we mentioned, the static server-side rendering is very similar to traditional web application, but it's also different. It is this enhanced navigation that makes the static server-side rendering different from traditional web application. So in this lesson, we're going to learn about the differences and the similarities between the static SSR and the traditional web application. So what I have right now is that we have the web application running. Now I'm going to bring up the developer tool by pressing on F12. And now let's go to the network tab and let's click on this refresh button inside the browser. Now you can see a lot of things are downloaded. And if we pay attention to this one, the localhost, this says the type is document. This is a full page load. Right? So this one single request means that the HTTP request went to the server side, and the server side processed that request and generated the HTTP response, and everything was downloaded to the browser side. And of course, we have some other static assets downloaded to the browser side as well. But because the type is document, this is a full page load, right? So this is the first HTTP request and HTTP response. This is the same, exactly the same as the traditional web application. However, the difference comes when we try to navigate between different pages. So let's try to do that. Now, I'm going to jump from home to weather. And when I do that, you can see that this is the newest request, right? The fact that it doesn't show up on the top is already telling us that there's something different. And what is that different thing? If we look at this type column here, this is no longer document, meaning that this is not a full page load, right? This is a fetch API. So if we actually pay attention to the web page, we can also see some differences. So if I go to home, and you can see the only thing that is changed is this part. The left part is not refreshed. The address bar, there's no spinning. The only thing is that the main body placeholder, right, in the main layout file is replaced by different components. So go to home, especially when I navigate from home to weather because it's taking longer time, you can see that there isn't a refresh on the left-hand side, right? And there isn't a spinning inside the browser. So what is causing this fetch API running instead of a full page load? If we go to our Visual Studio and go to app.razor, we can see that we have this script and it loads the blazor.web.js. What is this asset? We're going to talk about very soon. Let's just focus on this blazor.web.js. So this blazor.web.js is also loaded right over here. See, blazor.web.js, there is a hash thing. Again, we're going to talk about that very soon. So we have blazor.web.js. This is responsible for establishing the SignalR channel, which again we're going to cover in the future. But this blazor.web.js file also is responsible for the enhanced navigation, which is turned on by default. So each time we navigate, the blazor.web.js file is responsible to send a fetch API request to the server and then receive the information from the server. And then it does the comparison and smartly patch the page instead of reload the entire page. Okay, so let's go to our app.razor root component here, and then let's try to delete this one and see what happens now. So now if I run the application again, and actually it doesn't run. So let's actually, oh, okay, now it's reloaded. All right, so we have, let's go to home, and you can see that when I go to home, right, this type is document. And when I go to weather, again, this weather no longer shows up at the bottom, it shows up at the very top. And then it says the type is document. Now, if I just navigate back to home, again, localhost is showing up right here, and the type is again document. So what does this mean? This means that the navigation each time loads the entire page, right? It's no longer fetch API, it's the entire document. And every time this document is being displayed on the very top, which means that there's no JavaScript running, it's entirely just going back to the server and does the full load of the page. And this is exactly the same behavior as traditional web application. Whereas if we turn on the enhanced navigation by leaving this JavaScript file right over here, and then let's go back to our page. Let's wait a moment because it takes some time for it to take effect. I believe now let's go to home page, and you can see the localhost is being displayed at the bottom, right? And the fetch is being displayed as the type of this request. And again, if I go back and forth between these two, every time it's a fetch API that fetches the information from the server and then replaces, right? Smartly patches the differences, which it, in this case, identifies the only differences right here. So it just patches this area. It doesn't actually refresh the entire page. Whereas if I delete this and load this again, then what you're going to see is a refresh. And if I go to home, you can see the refresh button is actually spinning every time I navigate between different pages. That's the benefit of enhanced navigation. And that feature makes the Blazor static SSR different from traditional web application. So in this video, you can see that there's differences and similarities between the static server-side rendering and the traditional web application. It is this blazor.web.js, which is not a file that you need to worry about. You just need to include it. Microsoft already written this. It is this JavaScript file that is responsible to provide you with this enhanced navigation, right? And this is very similar to a interactive traditional application where you have to write the JavaScript yourself and load the data. With Blazor static SSR, with the enhanced navigation turned on by default, you're having this interactive behavior automatically by default. And that's thanks to our blazor.web.js file, which provides the enhanced navigation feature. Now let's quickly talk about this assets. So this is called static assets fingerprinting, right? In the past, if we don't have this at assets and we just leave it as this, so every time if there is an update to the static assets, there could be a caching problem because the browser tends to cache static assets. So deployment of changes becomes a challenge. Therefore, static assets fingerprinting is introduced. So what you're going to do is when you reference assets, you're going to use the add assets directive here, and it's going to automatically attach a hash every single static assets. In this case, it is our blazor.web.js file that has a hash name here, right? It makes sure that this file name is unique, so we never run into problem anymore. All right. That's everything about enhanced navigation and a little bit about assets fingerprinting. I'll see you in the next one.
This course is all about learning Blazor while we are creating an inventory system. Therefore,
in this video, let's talk about what is an inventory management system. So inventory management system is basically, you have some inventories and you want to manage them. Let's take this rectangle to represent a warehouse where you store, at least temporarily store your inventory. If this rectangle is the inventories, typically, at least in the inventory management system web application that we are going to create, we have a warehouse that not only store the raw materials, right, the inventories, but also we make products out of the inventory. So when we use the inventory to make things, the end results are the products. Basically from here to here, we have an action of produce. When we produce, the number of inventories decrease and number of products increase. There's another action here, which is when we sell products to the outside of the warehouse, the number of products also decrease. And that action is selling. Now we have producing, we have selling, and when we don't have enough inventories, what's going to happen, of course, is we need a shipment from outside to inside. This, we will call it purchase. In our inventory management system, we're not directly going to deal with shipping and receiving, but we'll deal with purchase orders. So when we have a purchase order and when we fulfill the purchase order, we'll receive inventories. Right? And when we purchase, the inventory increases. When we produce, the inventory decreases, but the products increases. And then when we sell, the number of product decreases. This is the inventory management system. On top of all of this, we're going to have a reporting module to report the number of inventories, the number of products, and how they change across different days, by different actions, whether it's purchase or produce and sell. We want to see the number of inventories before a particular action, like purchase. We want to see the number of inventories after that particular action, so that we can always track on what day, what have happened to the inventories or products. As management of your business, you want to be able to look into all these factors in order to properly manage your warehousing or your product producing or inventory purchasing. So this is the inventory management system that we are going to create with ASP.NET Core Blazor. In this video, we're going to talk about architecture, because very soon we're going to start coding, but what kind of architecture are we going to use in order to finish this pretty big system? Traditionally, we have the layered system, which, we have a database, right? And then we have our data access layer, depends on the database. Nowadays, we often call the database access layer repository. And then on top of that, we have business logic layer. And finally, we have our user interface layer. But this is not going to be the architecture that we are going to use in this course. We are going to use clean architecture. So what is clean architecture? So if you do a Google search, very soon you will find this blog post from cleancoder.com. So this is from Robert Martin. This puts everything in an onion structure, right? So you can see that in the middle, it's the entities. And then you have use cases and everything else, right? The entities are basically the models, right? The classes that will be used in all kinds of different layers, right? It's very important to notice that the dependencies are going inside, right? So the outer rings are dependent on the inner rings, not the other way around. So let's focus on the core. In my opinion, the core are both the entities as well as the use cases. So the entities can contain the model classes as well as some logic that is not application dependent, right? So it's basically a lot of validations. You're creating application that stores personal information, and there's this that state and the birth state. So a very, very basic validation is that the birth state has to be earlier than the death state, right? So those kind of logic is the core. It's not dependent on applications, right? Even when you use pen and paper, you are still going to have those validations, the same logic. So those logic will go into the entities layer along with those model classes. Whereas the use cases layer, which is one layer above that, that one stores the application logics. The logic in the use cases layer is for the application. So without the application, those logic won't exist. Whereas within the entity, those business logic are those logic that doesn't depend on any applications. Without existence of applications, you still have those logic, because even when you run your business with pen and paper, you still have those logic, right? And another thing, we can see that we have user interface on the outside, which is very, very understandable, because UI is always dependent on use cases and entities, right? But you have this database and you have devices, right? So the database and devices, those are I/O devices. Why? They are also outside instead of inside, right? So if we look at this typical scenario, the database is the bottom layer, means everything on top of that is dependent on database. Whereas in Clean Architecture, the database and devices are on the outside, right? So to understand this part, imagine you are creating Visual Studio. But you know that Visual Studio can have plugins, right? So let's imagine this is a plugin, right? And this is a plugin, and this is another plugin. So these plugins can be plugged into Visual Studio to extend Visual Studio's functionalities. You always create Visual Studio first, and then plugins can be developed by someone else. Not Microsoft, someone else, right? Because Visual Studio is developed by Microsoft, but anybody can create Visual Studio plugins. So how does that work? Well, that's very simple, because Visual Studios, when it's created, you need to create the interfaces so that when other people create plugins, they can just look at the interfaces. As long as they abide by the interfaces, then they can talk to Visual Studio, right? Visual Studio then can use them because of the compliance to the interface that's already created by Visual Studio team. So the key here is that the plugin interface is created ahead of the time. Same thing here. When you create use cases and when you want to talk to the database to pull data into your use case to use, your use case layer shouldn't be dependent on the databases or a file or API, for example. They should be the other way around, which means your use case layer, right? Use cases layer should contain a bunch of interfaces, right? And then your use case will talk to the interface, and then you will create the database layer as plugins to plug into your use case layer. That's why you have your database or devices layer on the very outer ring. So the keys to the clean architecture are not those technologies or the tools, but these two things: use case driven and plugin based, right? So you always look at the use cases first. You create the use cases first. You drive your software development by use cases. Of course, you can have your unit tests on top of use cases to do test-driven development. But even when you do TDD, you still think about use cases and what use cases you want to test. And then you can start with your testing layer and go into the use cases layer, go into entities, create your database interfaces within this use cases. And then you can plug in your database repositories into your use cases, right? So the first key here is use case driven, and the second key here is plugin based, right? Use case driven is referring to the core, and the plugin based is referring to any IO devices. Any IO operations will be in the DB layer that is outside of everything, right? It's the outer ring. So that's clean architecture. And if you don't understand, because this is very theoretical, in the rest of our course, you will have a lot of opportunity to see how it actually goes when we write the code. And of course, I have a separate course for clean architecture. You can look in my website, frankliucs.com, and find the clean architecture course.
In this video, we're going to start writing our first use case, and this use case is used to view inventories. Therefore, I'm calling it view inventories use case. And let's take a look at this mockup first. This mockup is for displaying inventory list. So therefore, you can see we have a search bar here, we have a view button here, and we have the list below the search bar. And when the user enters a few letters here and click on the view button, the list will be displayed. Right? It contains a list of inventories, and the name has to contain the letters that are entered in the search bar. So that's our use case. And we have another alternative use case. These are related use case. Okay? That's why I'm saying this is alternative use case. So this is when the user leaves the search bar empty and click on the view button, then the result is displayed, and this result contains all of the inventories in the data store. Now that we have seen the mockup, let's start writing the user story.
I'm just going to use Notepad to work on this. You can start with a user story sentence, right? So you can say, as a user, I can view inventories as well as search inventories. Better say, I can view all the inventories as well as search certain inventories by names so that I can manage them, right? So this is basically a very simple statement as a user story. But to provide more detailed information, we're going to continue writing as a use case. So for use case, we need preconditions, post conditions, and we need detailed steps, right? So this is a main scenario where the precondition is the user is on the inventories page, and the post condition is the user sees the inventories that meet condition. The detailed steps is the first step is the user enters few letters in the search box, and the user clicks on the view button, right? So after this, then it will reach the post condition. And then of course, we can have our alternative scenario A, and in here we are going to have also the 3 sections, but if the precondition is the same, then we can delete them. And in here, the alternative scenario A is when the user doesn't enter anything, basically keeps the search box empty, and then click on the view button. So we have the same precondition, so we can delete this. And then the post conditions, basically the user sees all the inventories. And detailed steps is the user makes the search box empty. The user clicks on the view button, right? And this has to be changed to 1A and 2A. So basically 1A replaces this number 1 here, and 2A replaces this number 2 here. And after that, we go into the post condition here, and this has to be 2A. So this 2A also replaces number 2 here. The reason why we want to do this is because if we have a lot of steps, for example, in the detail steps in the main scenario here, then if the alternative scenario does not require you to change all of the steps, in this case, it's probably not a very good example. We are changing all of the steps. Actually, see, the user clicks on the view button is not being changed. So we don't even need to mention this. So it's basically when you write alternative scenario, you don't have to repeat all of the steps, right? You can just mention the ones that needs to be replaced, and then you just need to specify the number correctly, right? So this corresponds to A here. So 1A basically replaces this. So this is what we are going to implement, the first use case. In the rest of the course, I'm not going to write all of this because I want to save you some time. But for this first use case, I'm writing this as a template for you. I do suggest if you want to follow use case driven development, or even not use case driven development, but still requires use case, I'm just having this template as example, right? You can write your use case differently, but this is how I write my use cases. If you have a QA team or QA person, they can take a look at this documentation and test accordingly. For us, because we are developers and we are in this project, at least in this course, we're doing use case driven development, right? Clean architecture. So we do need a use case documentation like this. So in this video, I just wanted to show you how to properly write a use case so that both developers and QA team can use the documentation for development as well as testing.
In this course, when we build our application, we're going to follow clean architecture. And for that, my interpretation is that we need to follow use case driven, plugin based clean architecture. So therefore, we will have to start implementing use cases. And in this video, I want to explain to you why we need to start with implementing use cases layer.
Some people said to me that this is still a layered architecture, not clean architecture. But I have to tell you that actually clean architecture is layered architecture. It's a type of layered architecture. The only special part is that it has the center, and the center is entities and then use cases. And the database is not in the center. Database is the outside layer, right? So that makes this clean architecture. And those two key things that I mentioned, use case driven and plugin based, those makes a layered architecture clean. So in this video, I want to explain to you why we want to start with use cases just a little bit, because business logic is the purpose of this type of business applications, right? We're writing the application to implement the business logic. That's why we want to start with the purpose and with the purpose, right? Because creating the application is not the purpose. Using a particular technology is not the purpose, but implementing the business logic is the purpose. And also because the use cases layer implements business logic. That's why we want to start with use case. The second reason is that when we implement use cases, these use cases makes our developer focused on the business logic instead of user interface or database. So it's not UI centric, it's not DB centric, but use case centric. And because our use case layer is not technology dependent, therefore you can use the use case layer in any type of applications. Whether it's mobile applications or desktop applications or web applications, you can use the use case layer. In some cases, like a mobile application, you may want to use web APIs to wrap around the use case layer to expose the functionality outside. In other applications,
like Blazor application with server interactivity,
you may want to skip that web API layer. Like in our project, we are going to skip the web API layer. But if you want to write a
Blazor application with WebAssembly interactivity,
then you will have to wrap the use case layer with a web API in order to expose the functionalities outside from the use case layer. And that's what the gateways, presenters, and controllers are.
And for those reasons I have stated, we will start our development with writing use cases. In this video, let's start writing the view inventory use cases. And let's jump into Visual Studio and start with creating a new project. So we're going to go right-click on the solution and add a new project. Let's search class library. We're going to create a class library project because we don't want to put the use cases in the web app application, which is the Blazor application, because this class library includes all of the use cases, and the use cases can be used in different applications. So we don't want to log everything into our Blazor application. Therefore, we're going to create a separate class library application. So select this, make sure this is language is C#, and click on Next button. Here, let's take a look at the folder structure here. So you can see the folder structure is like this, and we're going to create a project name that is called ims.usecases, and click on the Next button. Now,
the framework is .NET 10.
Now let's click on the Create button. Now our project is created. Now let's take a look at the folder structure. Make sure the folder structure is correct. So right-click on the solution node right here, and click on the Open Folder in File Explorer here. And let's examine the folder structure. So we have this root folder right here, IMS, and then we have the ims.web application, we have s.usecases, and under each one of them, we have our projects, right? So the project right here, and also we go to use case, we have the project file right here. So this is the perfect file structure that we're looking for. Now let's come back to our Visual Studio and start by creating the use cases. Now this is the use cases project, and it's going to potentially contain a lot of use cases. We want to provide a logical grouping for these use cases. And there are different ways to group the use cases. For example, by screen, right? Each screen could have different use cases. When I say screen, it's just the screen of your application. Or you can group the use cases by concept. In this course, I want to group the use cases by concept. In some other courses, I group the use cases by screens. So the reason why I'm not so consistent here is that I want to show you there's a different possibility to do things. It's really up to you to decide whether you want to choose one approach or whether it's the other approach. So because we are creating this first use cases for inventories, right? For viewing inventories, there are a lot of different things we can do toward inventories. Therefore, inventories is basically a concept in this business logic. So let's right click on the use cases project and let's add a new folder and let's call it inventories. Now I'm going to right click on this folder and create a new class. And I'm going to name this class after view inventories use case. So all of my use cases will end with this word use case. And just so that we know, these classes are for use cases no matter where we see them. So click on the Add button. And now we can delete the class1.cs under the root folder. We don't need it anymore. Click on OK to delete it. Now let's work on creating this first use case. So let's read this first use cases again. Precondition is the user is on the inventory page. And in the detail steps is that the user enters a few letters in the search box. And then the user clicks on the View button. The post conditions that user sees the inventories that meet the search condition. I wasn't very clear here how to match the conditions, so let me explain. I think we should use contains. Okay, so the letters that are entered in the search box right here will be used as contains condition. So any inventory's name that contains these letters will be in the search result. And the returned result will be a list of inventories. So let's jump into Visual Studio and implement that. Okay, so first of all, this view inventories class is internal, and let's change that to public because we want to use it from outside of this project. And the view inventories use case, I think I need to change it to view inventories by name. This is more clear. And let's also change the file name to view inventories by name. And right inside this class here, we want to have our only public method. And that is going to return us with a list of inventories, right? So therefore, I'm going to say IEnumerable inventory. I know I haven't defined inventory class, but let's start writing it without defining it first. So this is more like TDD, right? Test-driven development. You're going to write it and you're going to create these squiggly lines, these errors. And then you go ahead and fix these errors. That's test-driven development. We're doing use case-driven development. It's similar concept. So you start writing your use case, and then you're going to fix these errors. It's going to return us with a list of inventories. And here, the method is going to be called execute. And I want to use async method. Therefore, I'm going to have the suffix as A, S, Y, and C. And then we're going to use it for searching inventories. Therefore, we need the function to pass in the name. And we're going to define the default parameter, because if the caller doesn't provide the name, then I'm going to return all of the inventories, right? So now we have this problem here. We have this red squiggly line. We want to get rid of this error. Therefore, we need to define this inventory class. Then where do we define the inventory class? If we look at this clean architecture, we can see that within the core, we have use cases and we also have entities. The entities is basically the core of the core, and it contains all of the model classes that we want to use, including, in this case, our inventory class. So the inventory class is inside the entities layer. And I don't want to call it entities. I want to call it core business, right? Because that's the core of our business. And implementing business logic is the whole purpose of writing application. Therefore, I'm going to create another class library. Why do I need to do that? Because another class library corresponds to a different layer. Here, the entities is another layer comparing with the use cases. You can see the different colors, right? And some of my students are really confused by having so many different class libraries, right? Different projects, and they just want to learn Blazor. Why do we need so many class libraries? Well, keep in mind that this course is not only all about Blazor, it is also project-based course. I'm trying to prepare you for implementing your own projects in a team environment. If you work in any companies, they will not give you a project that has only one Visual Studio project in it, right? Any projects that you work on, you will have similar layered architecture, because these are dominant architectures in modern days. Whether you use clean architecture in my way, or you use clean architecture in a different way, or you use other type of architecture, there are going to be layers you can't get away from that. So you have to get used to have multiple layers. So let's jump back into Visual Studio and start creating the core business layer. So right click on the solution and add a new project. And this time it's again a class library. Click on next. And we're going to call it properly ims.core_business. And I have explained why I call it core business instead of entities. And click on next. Again, we're going to select .NET 10 and click on create. And here our class name is inventory. So what is defined in the inventory class? Let's don't worry about it because it's use case driven. Let's focus our energy on implementing the use case. Now our energy is trying to fix the red squiggly lines, right? So we define the class here and we change the class name right here. And now we just need to come back to use cases and add a project dependency. And let's take this and click on OK. So we create a dependency from use cases to core business. Right? You can see that right here. And if we go inside here, we do a control dot to import the namespace. And if we choose this, then you can see the red squiggly line is gone. Now let's go ahead and try to implement this method. So what are we trying to do? We are trying to execute this use case. And this use case is for searching inventories by name. And where are the inventories stored? The inventory is stored in data store. Whether we implement a data store with a file system, with a database, or in memory, it's up to us. But as you have seen in the Clean architecture here, the devices, the database, external interfaces are the oldest ring, right? And our use cases are actually not dependent on them. Our use cases is dependent on the interfaces. So let's don't worry about how we're going to interact with the data store, whether the data store is a DB, a database, or a file system, or on other devices. It doesn't really matter. What we want to do right here is to create an interface and assume we already have the functionality implemented. So this part is the plugin based architecture, right? So use case driven and plugin based. We are going to have a lot of plugins. Therefore, we're going to create a folder under the use cases project. Remember, the interfaces are sitting within the use cases. And then the outside layers will implement those interfaces. And you can even delegate those tasks to other teams or other companies. You can just provide them with the definition of the interface, and they are going to implement the concrete implementation. Therefore, for now, our focus is to implement the interface. So I'm going to say plugin interfaces. This is the name of the folder, and we're going to implement our first interface. And let's don't worry about this interface. Let's assume we already have the interface. Again, use case driven development. If we already have the interface, we're going to use dependency injection to inject the interface into our use case. So I'm going to do ctor, which creates our constructor, and we're going to use constructor dependency injection. We assume we have an interface, and inventory repository, that's the name of the interface. Now we can initialize it. You can see that we are assuming we already have the interface, but we don't. Therefore, we have another red squiggly line. But don't worry about it. Let's do a control dot right here to initialize this variable. And let's come over here and use this inventory repository. So we're going to use this inventory repository to actually complete the work of viewing inventories by name. So therefore, I'm going to pretend I already have the function inside the inventory repository here. So I'm going to say get inventories by name async. And we're going to pass in the name variable here. Because this is going to be an async method, and therefore, I'm going to return with the await keyword here. And this is async method. Therefore, here I'm going to add an async and a task. Now you can see that the red squiggly line here is gone, but here the red squiggly line is still there. That's because we haven't implemented the interfaces yet. So let's go to the plugin folder and click on new item, and we're going to create a new interface, and we're going to paste that over here. So click on add. We're adding this interface right here, and we want to have this as public instead of internal, because these interfaces will be used by outside, right, by other projects, and those are the actual concrete implementation of the plugin. So here we will need to have our actual function defined here, but what we can do is we can jump back into here and let's do a control dot to import a namespace. Now you can see we have a right squiggly line here again, and now we can do a control dot again right here to generate the method. And you can see we fix all of our right squiggly lines. Let's go back to the interface definition here. You can see that it automatically generated the interface function for us. So what we have done so far is that we have implemented this use case ring, and also it's the internal core business ring. And we have also implemented this interface. Therefore, we have a complete core for this particular use case. And the next step is to actually implement the repository, okay, based on the interface that we have already defined. And then after that, we can dependency inject the concrete implementation of the repository. So that's plugin based. And we're going to do that in the next video. In this video, we are going to implement this abstraction to help the use case to get inventories by name. To do that, we will need to create a plugin, because a plugin is plugged into our application, so it's replaceable. To demonstrate that, I want to create an in-memory plugin first, and then later we can replace that with another plugin that is made of Entity Framework Core. Because of that, I may have different plugins. So first of all, I need to create a folder. So I'm going to add a solution folder under the solution, and then I'm going to call it ims.plugins.
And this is a logical grouping. So there isn't a folder actually created for this under the file system. So if I go to File Explorer, and you can see we don't actually have a folder corresponds to the IMS plugin. So I'm going to actually create a physical folder here. So I'm going to call it ims.plugins, which corresponds to our logical grouping folder right here. Now I'm going to right click on this folder and then add a new project. And I'm going to select class library as well. Click on next and come to this location. Make sure this is under the correct location. So go over to IMS and select the IMS plugins folder. And now we're going to create this new project under the plugins folder. And it's going to be called IMS plugins.in-memory, because we're going to create an in-memory data store. Later, when we create a Entity Framework Core data store, we're going to call it IMS plugins.efcore. So there can be different plugins created under the ims.plugins folder. Let's click on next. And framework, of course, we're going to use .NET 10 preview. Click on create.
Another benefit of creating an in-memory plugin is that you can use it for testing to facilitate your test cases so that you can have a fixed set of data to test with, so that your data does not change, right? Because if you use database, the data in the database will change over the time, so which will make your test cases fail. But if you use an in-memory database that have a fixed set of data to start with, so you always will have the same data to work with. So in this in-memory plugin here, I'm going to have a inventory repository, right? And this will implement the inventory repository interface in the use case layer. So that's why I need to add a dependency here, right? A project dependency to the use cases layer. So this reflects the clean architecture, where you saw that the data store layer, which is the outside ring, is dependent on the use case layer, as opposed to the other way around. And then I'm going to do control dot to import the namespace, and do another control dot to implement the interface. Right now, I only have this one method here. So then here, I am going to hard code some data here for a list of existing inventories. Okay, so I'm going to call it inventories. The inventories will be populated with some data. So now it's the time to give our inventory some field in order to initialize the inventory list with a list of inventories. So then to do that, we can go to our core business layer. We can add some property in here. So of course, inventory class will have an inventory ID, and then we will have a inventory name. Do we ever allow our inventory name to be null? No. Because of that, I'm not going to put a question mark here, right? I'm going to initialize it with empty string. Now we have the quantity property as well as the price of the inventory, basically the cost, right? And then we can go back and we can initialize something. So let's say we are producing bicycles, right? So let's call it bike. And for bike, what kind of parts do we have? We have bike seats, and let's say we have 10 already, and the price is, let's say, $2 as a cost, right? And then we will have bike body, and we also have 10, and bike body is, let's say, $15, and we also have bike wheels, let's say we have 20, and then each cost $8. We will also have some bike pedals. We also have 20, and let's say each cost $1. Now we are going to implement this method, and first we'll need to check whether the name that is passed in is null or white space. If it's null or white space, we are going to return everything. And here, because we're using a task, and also because we're using in memory, so we can use task dot from result. We can just make it async, and then we do a wait. If the name is not empty or white space, then we really need to filter the list that we already have in here. And for that, we can use the inventories dot where, and we can use the inventory name dot contains the name, and we are going to use the ordinal ignore case parameter here, and this where method returns I enumerable, right? And that's what we want. So we implemented this abstraction. Therefore, this inventory repository class can be used as a plugin. Then how do we plug this into our use case? What we need to do here is that we need to register this interface and its implementation in the service collection in our Blazor application.
We will need to come to this web application and open up program.cs. This is where we do dependency injection. We will need to add our inventory repository plugin to the service collection right here. So if you look at this add razor components method, this is actually an extension method. So if we go to the definition of this, you can see that inside this extension method here, we have the add singleton, add scope method being called. So these methods are being called for adding dependency injections into the service collection. And we are going to do the same, except that we are going to do it right inside the program.cs. We're going to say services.add singleton. So I'm going to explain to you what is singleton later, but right now I'm going to just use I inventory. So of course, in order to do this, we have to actually add the project references, and the web application is the infrastructure of the whole project. Therefore, it's going to be dependent on all of the other projects. I'm going to select all of them and then click on OK. And now I should be able to reference the I inventory repository interface, and then our concrete implementation, which is under here. I'm not actually going to have the namespace right here. I'm going to just do a control dot to import a namespace, which is being showed right here. So what this means is that we have a concrete implementation and we have a interface. This tells the service collection that whenever the interface is required, this concrete implementation should be used. So how this works is that when the use case, whenever use case, this particular one, is required by the web application, it's going to look at the constructor here and it's going to realize that this particular use case requires the concrete implementation of this interface. And then it's going to go to the services collection over here, and then it sees that the concrete implementation is provided right here, and this comes from the in-memory data store right there. Then it's going to go to our in-memory data store to grab this definition and create an instance of this class. And then the instance of that class, which is this one, will be provided to the constructor of this use case. And now this private variable here will have the instance of the in-memory data store right over here. So this completes the process of plugging. And in the next video, we are going to see how this use case is used in our Blazor application. In this video, we are going to use this use case in our Blazor application. And to do that, we are also going to use dependency injection. For that, first of all, we will need to create an interface for this use case. So I'm going to do a control dot on here, and I'm going to select the first one, extract interface, and click on OK. So automatically Visual Studio does the work for me. So it created this interface right here. Now for file organization purpose, I'm going to create a folder so that I can put all of the interfaces inside this folder, because I know that under inventories folder, I'm going to have other use cases. Now that I have the interface for the use case, I can again go to the web application and then go to program.cs where we do dependency injection. And here we're going to say builder.services.add transient. So like I said before, we are going to have a separate lecture about dependency injection. So don't worry too much about what transient means for now, because for now, we're going to just register a mapping between the interface of the use case. So I view inventories by name use case, and then the concrete implementation of the use case itself, which is the same name without letter I. And now we should be ready to inject the actual use case into our Razor component. When I say Razor component, what I mean is our Blazor components, because in Blazor, a component is called a Razor component. So let's go inside this folder, right? Components folder, and we have this pages, right? Let's go to the home page, which is the root page over here. And here it's called home. Let's change to test page. Okay, here. I don't want to create a Razor component yet. I want to reuse this component to show a list of inventories. So I'm going to have a couple of line breaks so that it just looks better. And now I need to add a code block. This is where you write your C# code. So your C# code is written within the code block over here. And then that is only C#. And then your variables defined inside the code block can be used inside HTML, and that's called Razor syntax. And I will show you in a moment. So first of all, let's declare a variable. Here, the purpose is to display a list of inventories that we have in memory data store here. Therefore, we need a list of inventories. So I'm going to declare a variable that is of the type of list inventory. And I'm going to go over here and do a control dot to import the namespace. Now, over here, if I do this, it has a green squiggly line here. So we can use a question mark to declare to Visual Studio that this variable is nullable. And now we're working with Razor components, and when Razor components instantiate itself, it goes through different lifecycle events. And one of the lifecycle events is called uninitialized. So basically, when the component initializes itself, the lifecycle events uninitialized will be triggered. And that's where we initialize our state variables here. And this is the one that we define here. So what we can do is we can say override, and we can say uninitialize. And because our method in the use case is asynchronous method, therefore we're going to override the asynchronous version. If you have some method you need to call, but there are synchronous version, then you can use the uninitialized. But here I'm going to use this asynchronous version, and I can just basically delete this. It's not very necessary. And here I can use my
use case. In order to use the use case, we need to do dependency injection. We need to inject the use case into this Blazor component. And to do that, we can go to the top, and over here, we can just say inject. Now we're going to say I view inventories by name use case. And we can do a control dot to import namespace. We can do it this way, or we can copy these and actually cut it into the imports.razor. So this is where we can centralize our using statements. So by doing it this way, we don't have to use the using statement in each and every single component. So right now I put it in the imports.razor. This is the central place. And then when I go back to home.razor, you can see that this I view inventories by name use case interface is already changed color. So this Blazor component is aware where this comes from. We don't have to import the namespace in this particular Blazor component. And right over here, I can just give it any name that corresponds to this use case. Now, when I have it, I can start using the use case in the uninitialized async method. This means that when the component is being initialized, I'm going to call the use case, and I'm going to call the execute method here. And here, I don't want to provide any parameters. That means the use case is going to give me all of the inventories. If I hover over this, you can see the return type is IEnumerable inventory, whereas the variable here is list inventory. Therefore, I have to convert it to list. And because this is an async method, I have to use await. And here, I have to use async. So async and await, those are pair of keywords that we have to use together. So async here and then await here. And I'm going to use brackets and then do a to list. So this would convert my IEnumerable of inventories into list of inventories. And here I can assign it to my inventories variable right here. Now I can spit out the inventories in the HTML. So this is the HTML section, and this is the C# code block section. In the HTML section, it's not pure HTML. We can use our C# inside here, and this is called Blazor syntax. And in Blazor syntax, we can write C# per normal, but we have to start everything with the @ sign. First of all, we want to make sure that inventories is not null because it's declared as nullable. And it's possible that this method returns null to us. It's possible. So therefore, we want to be using defensive programming. Therefore, we have to say if inventories is not null, then we can safely loop through this inventory list. Okay? And perhaps we can add something. We can say inventories.count is greater than 0 as well. Inventories.now and inventories.count is greater than 0. In this case, I'm going to loop through. So I'm going to say for each var inventory in inventories. So you can see I'm just writing C# normally. However, here I want to output HTML. So which means that I'm mixing C# and HTML. Here I can just start writing HTML and I can say li. So I want to display the inventory name inside a list. And right over here, if I say inv, you can see that this color is different from this. This is dark blue, but this is black. So which means that Visual Studio is considering this as a string, right? As part of HTML. The reason why this is not considered as C# anymore is because once you start writing C#, you use the @ sign. But then if you mix HTML in it, the flow of C# is broken. Therefore, everything inside it is considered as normal HTML. So if you want to start writing C# again, then you have to use the @ sign here. And then I can say inventory name. Now this is not complete because we're using the li element. That means outside it, we have to use an order list. So I'm going to say ul over here and then wrap this around and format this a little better with indentation here. All right, so we have ul, an order list, and then inside it, we're doing a for each loop in order to create a list of li elements in order to show the inventories in the list. Okay, we finished coding here and let's give it a test by running the application. As you can see, we have all of our bikes listed on this homepage. If we go to weather page and we come back, you can still see the list is rendered over here. Let's do a little bit more testing over here. So go back to the home page here and let's test the functionality of filtering the inventories. So let's say WHE, and I'm expecting to see the wheels only, right? Just the wheels. And let's run the application again. So let's go to the application. We can see the bike wheels, and that's expected. Only the bike wheels should be showing here. And another test case could be we entering something that doesn't really exist. And let's run the application. The expectation is we don't see anything. Now you can see that the bike wheels even disappeared. So basically we don't return anything in the inventory variable. And because we have some conditions over here, so if the inventory's count is greater than 0, then it's going to loop. So what is happening here is that the inventory doesn't contain anything. Therefore, this C# code is not being executed and we have an empty UL list. All right, so in this video, we have learned a few things. One of the first thing we learned is to inject the use case into our Razor component. This home.razor is a Razor component. And because we need to use the use case, therefore, we're going to inject this into this Razor component with the simple directive @inject. And then you provide it with a name. Any name is possible. I just like to use the name of the concrete implementation, which is after the letter I. Doesn't really matter what you call it. And then in the uninitialized lifecycle event here, we are using the inventory use case and we're loading the data into the local variable here. So let me clean this up for now and let's continue. So we have the data loaded into the inventories variable here. And in the HTML section, we are using Razor syntax to loop through the inventories variable and generate a list of li elements. Let's rerun the application again. I want to show you the HTML here. So we generated this bike C spec body, this list of inventories. And let's press on F12, which is a developer tool, and make sure we highlight elements. Then we use this arrow here to examine our HTML. So inspecting HTML, we can see we have UL elements and we have 4 different UL elements generated by our C# code. Right? We have everything cleanly generated with our C# code, and this is the beauty of Razor syntax. And that's everything I want to cover in this video. If any questions, please let me know. If not, I will see you in the next one. In the past few videos, we have been using dependency injection. And one of the first things when we use dependency injection, we notice that we are injecting an instance of the object from outside into the class here. So this is constructor dependency injection. The instance is coming from outside into the constructor directly, and then we use it inside the class. So this is the use case. And in the Razor component here, we also use the @inject directive to inject the instance of the use case from outside, right? In either of the cases, we did not use the new keyword to instantiate the class and create an object. Here, we didn't use a new keyword. And in the use case here, when we inject through the constructor, we did not use the new keyword. So what is really dependency injection? I have explained this concept in different courses using different ways. This course, I'm going to use again another way to explain dependency injection. Right? So for example, we have our use case here, and this use case class needs to use the repository class. Typically, without dependency injection, you would create this repository class instance right inside the use case. By doing that, the use case class is responsible for controlling the lifespan of repository, which creates a closely coupled relationship. The use case class needs to know the definition of the repository class. As soon as the repository class gets changed, the use case class will need to change accordingly, or at least gets recompiled in order to keep up with the change of the repository. Basically, the higher class will need to be responsible for a lot of things for the lower level class. And when this use case is used within the Razor component without dependency injection, the same thing would happen
And in that case, our Blazor component will also have to be responsible for instantiating the use case class and be responsible for managing the lifespan of the use case class, which again creates a closely coupled relationship between the Blazor component and the use case. So you can see that without dependency injection, you have a chain of classes all chained together and knows each other one by one by one. And all of them are closely coupled. So when we have dependency injection, what actually happens is that we have all of these classes registered within the framework. So we have our framework right here. And then instead of having our use case here inside the Blazor component, our use case is registered in our framework. Of course, our repository is also registered within the framework. Now, when our Blazor component is initialized by the framework sees that the Blazor component requires an instance of the use case. And it goes into its service collections and it sees that the use case is registered in the service collection. So the framework is then responsible for creating an instance of this use case class and then feed that instance of the use case class to the Blazor component. While it's creating the instance of the use case class, it noticed that the use case class also requires an instance of the repository class. And because it's also noticed that the repository class is registered with the framework as well, so it is able to create an instance of the repository class and feed that class to the use case. Therefore, it completes the creation of this chain of dependencies and then inject the use case into the Blazor component. Blazor component is then able to use the instance of that use case class to complete the business logic that the Blazor components requires. Let's again look at our code here. So in the home Blazor component here, we are injecting the use case into the Blazor component because the Blazor component needs to use the use case. And when the Blazor component is instantiated, the framework notices that it requires the use case. Then it goes to the dependency injection container, which is that services collection in the program.cs file. And it noticed that it has already registered the mapping between the interface and the concrete implementation. Therefore, it starts to instantiate this use case. And when it tries to instantiate the use case, let's go to the definition of this use case. It notices that this use case actually requires an instance of this inventory repository. Go back to the dependency injection container, and that's the services collection here. And then notice that again, there is a mapping between the interface and its concrete implementation. Then it tries to create an instance of this inventory repository concrete implementation. Right? Then it go inside this over here and notice that this one doesn't require any dependency injection anymore. Therefore, it create an instance for this and feed it to the use case. And then when it feed to the use case from the constructor here, then the instantiation of this use case is completed. When it's completed, it is again inject into the home.Blazor, this Blazor component. And from here, the entire chain of dependency injection is finished. Therefore, you can see the sequence is that from our Blazor component, it requires the use case. From our use case, it requires the plugin, right? The inventory repository plugin. So that's the chain of dependency injection. And this dependency injection enables our clean architecture. It enables us to be able to create a repository, right? A data store layer as a plugin that is plugged into the core of our clean architecture, which includes the use case as well as the entities, right? The core business layer. In this video, let's talk about lifetime management in dependency injection. So in the program.cs file, this is where we register the dependencies inside the dependency injection container, which is the service collection. And when we do that, you can see we have an interface and the concrete implementation, another interface and concrete implementation. So this registrations allows the dependency injection container to know the mappings between interface and its concrete implementation. But that's not enough for dependency injection because the services collection, which is the dependency injection container, also needs to know about the lifetime, okay? How long it should keep the instantiated object in the memory. And that's why we use different methods here. So for example, this one is at singleton, this one
is add transient. Okay? They indicates the lifetime of the created object. So let's first cover the add transient. Add transient, as the name indicates, this object is created every time when the program requires. Because of this, every time, whether it's a class that needs the instance of the use case, or it's the Blazor component that needs the instance of the use case, every time when the program requires the use case, it's going to create a new object. That's why we use add transient here. Let's go to the definition of the use case. You can see the use case actually doesn't store any data. Therefore, it's pretty light and it can be created every time that the program requires it. Now, let's talk about add singleton. Add singleton means that the first time that the instance of the class is required, it will create it. But then at the same time, we're going to store that within the application. And then it's going to live as long as the application before it's disposed. Comparing that with the transient. For the transient, when the object is created, it's going to be passed to the class or the component that requires that object. And once the class or the component is disposed, this object instance is disposed right away. Whereas here, for add singleton here, we're saying that this object is going to live as long as the application once it's created. Right? And the next time when a class or a component requires this instance of the class, it's going to retrieve the instance of the class from the dependency injection container, right? Because it stores that for the lifetime of the application. So we covered add transient, we covered add singleton. There's actually another lifetime span here, which is add scoped. So scoped lifetime management actually indicates different lifetime, comparing between server interactivity and WebAssembly interactivity. For example, let's look at this diagram here.
This is interactive server-side rendering. And the main feature of interactive server-side rendering is this signal channel.
Let's make it silverish. So signal channel here is a connection between the browser and the server. It's a constant connection, it's a WebSocket connection. So when we say add scope here for interactive server-side rendering, we're basically saying we are going to create an instance. Let's say instead of using add transient, we're using add scoped for this particular use case. And let's comment this out. So this means that when this is required, you're going to create this use case, but it's not going to dispose this use case instance right away. It's going to store it for as long as the signal channel is established. So for example, if I just refresh the browser, that refreshing of the browser is going to break the signal channel and then going to reestablish the signal channel. Because the signal channel is broken, the instance of this particular object is going to be disposed because it lives as long as the signal channel. So that's the scoped lifetime
for interactive SSR.
But if we look at WebAssembly interactivity here, if you have a component that is marked as
interactive,
then that component is going to be downloaded to the browser. It's going to run inside the browser as WebAssembly. Because it's downloaded to the browser and there is no signal channel, that means the scoped lifespan is the same as singleton. It's going to live as long as this component is still inside the browser. In our case, we don't want to use add scoped for the use case. We just want to use add transient for the use case because the use case is a pretty light class here. It doesn't store any data. Therefore, we want to use transient. However, for inventory repository, this is a in-memory representation of a data store. Right? It acts the same way as a database. Imagine a database is there. It is always there. It doesn't go away. It even persists in file systems. So that is definitely a singleton lifespan. Therefore, we are using singleton lifespan for the data store. However, we're using transient lifespan for use cases. So this is lifetime management for dependency injection. In this video, we're going to talk about page component, and we're going to use the page component concept to actually create a page component. Just so that you know, sometimes a page component is also called rootable component. As you know, Blazor is a single page application framework. So in theory, there's only one page, which is the page down here. So open up the components folder, and this is the page. We have seen this in the project structure video. This is the single page. So then you may ask, what do you mean by creating a page component? Right? There's no such thing as a page other than this app component. Well, notice that we have this router component. So let's go inside this routes.razor. This is the router component. This router component goes inside the correct assembly. Currently, it's the local assembly, which is the assembly for the web app application. It goes in there and tries to find corresponding route, the corresponding page component. So for example, in existing pages here, we have this home.razor. This relative path is the root of the application. And if the user requires for the root of the application, then the router component will be able to go inside this local assembly and find and locate this home.razor. Right? As I mentioned in the project structure, you know the entire loading sequence, this router is the key component that helps us to locate the page component. So therefore, we are going to create a page component and let the router component do all the hard work. It does the heavy lifting. All we need to do is just to create the page component. And in order to do that, let's go under the pages folder. Let's first of all add a folder because we're going to have multiple pages for the concepts of inventories. So we're going to say inventories. And now we're going to right click and click on add and select Razor component. Don't select Razor pages. So here you see it generates the default name here is component.razor. So if you come from React or Angular background, you may have a tendency to keep this component suffix here, but I want to delete it so that I know I'm creating a page component instead of a reusable component, but it's really up to you. So here I want to call it inventory list because this is the place where we're going to list out all of the inventories. So click on the add button over here. And let's add a space over here. Okay, so this is a component, but it's not a page component yet. The single most important thing we need to add to a component to make it a page component is this add page directive. So this add page directive indicates the relative path for this particular page component. So if I do the slash here, you see this, I have already provided a relative path for this page. However, Blazor doesn't allow two page component that has the same relative path. So let's go to home.razor here. You can see that this home page is already using slash, right, which indicates this is the root of the application. Here, we're still using slash. This indicates this is also the root of the application. So therefore, there is a conflict. Can't allow the situation to happen. So here, I'm going to add something. So I'm going to call it inventories. So this is the relative path for this page. And we should be able to use this path to navigate to this new page here. Well, there's nothing on the page, but we can already looking at it by running the application. So let's run the application and see whether we can navigate to this new page that we created. Now we have our application running, and this is the home page. So in order to go to the new page component that we created, we do slash, and this is the relative path. So this takes us to the new page component that we created right over here. So you already know the loading sequence, and you already know that it is this router component that does the heavy lifting. Right? So this is the single page, and inside the single page, we have this router component. This router component is right over here. Knows which assembly to look for the page component. Then it goes through all of the pages inside this application in order to locate this based on the relative path. In this case, it found it right here. Then it loads all of the HTML based on the logic that we provided here. Well, we didn't provide anything. It's just a simple HTML element with two words over here. I just want to let you know before I finish over here, there's this router component. You can see you can add additional assemblies. So in case that you want to create your Razor component in other projects here, then you have to add this additional assemblies over here in order to reference to that assembly. Then the router would be able to go into that assembly, right, that project to locate your page component based on path. One last thing I want to do before we finish is to actually go into this layout folder and go into this nav menu. So why do I need to go to the nav menu? So let's go to main layout here. You can see that on the left hand side is a sidebar, and the sidebar has the menu items. And then on the right hand side, we have this main area where our actual page component is going to be loaded and replace this body placeholder. So we want to go to the nav menu over here to add a menu item here. Let's keep this weather component over here. Let's just copy this and paste it over here. And here, we're going to say inventories. This corresponds to our new page component. And then here, we're going to say inventories. So notice this inventory is the same relative path that we provided over here. It's just that we don't need the slash in the nav link component. So this is also a component provided by Microsoft. You can see the namespace ASP.NET Core.Components.Routing. And this relative path points this to our newly created component right here. And if we rerun our application, we should be able to see newly created menu item right here. And if I click on it, it goes right here. It go to weather, it comes back to weather, go to home, this goes to the home page. Going back, we can see the inventory list page component.
And before I finish, I just want to point out what this nav link is. So why don't we use a plain anchor tag instead of using the nav link component? One of the main features of the nav link component is the automatic highlighting. So if we go to the page, and then if I click on weather, you can see the weather is highlighted. In order to show you more obviously, I'm going to just type in /inventories. And then you can see, even when you just use the address bar, when I come to /inventories, the inventory item is highlighted. And if I go to, let's say I go to home, the home is also highlighted. So that's the main feature. And another thing I want to say is that you can specify the matching mechanism here. Two options. One is all, the other one is prefix. If we don't specify the matching mechanism, the prefix one is being used. The difference between the prefix one is all is that if we specify all, that means we need an exact match between the href and the URL in the address bar. Only there is a complete match. Of course, the domain name is excluded. Right? When that is excluded, only when the rest is completely matching with what is written in this href element, then this item is going to be highlighted. And if we're using prefix, that means that as long as the prefix matches, then the item will be highlighted. So in this case, we're saying that everything has to match. And if we don't specify this, which means that we're using the prefix one, then there's going to be a problem. So let's take a look. Let's go over here and we click on home. That's fine. But if we go to weather, you can see both the home and weather are highlighted. That's because /weather start with / which matches the home item. Go to inventory. You can see both home and inventory are highlighted. That's because /inventories start with /. That's why the home is also highlighted. And that's the reason why here by default, the template generates this match equals to all parameter setting here. That's what I want to talk about the nav link component.
And that's everything I want to cover in this video. I will see you in the next one. In this video, we're going to learn about single application framework's best practice in terms of breaking down components into smaller components. Blazor application framework is a single page application framework, and all single page application frameworks are component based. Which means instead of just having one big page, we're going to break the whole page into different components. And each component can be even further broken down into smaller components. This way, our application log can be scattered to all those components instead of all combined in one file, in one page. And especially because single page applications are usually stateful application. Although we're currently learning about the Blazor SSR, static server-side rendering, it's not stateful. However, these components can be used later for stateful purposes when we add interactivities to them. Therefore, we have to learn how to break components, big components, into smaller components. So I want to use this first inventory list page as example, right? We see that we have the search box here, right? This search box here, it helps us to find the inventories that we want to see, right? Helps us to filter the inventory list. This is a perfect example for a reusable component. So basically we need to create a reusable component and maybe call it search inventory, right? And then we have this part of the screen. This represents a list of inventories, right? So again, this is another component. But even within this component, which we can call it inventory list component, each inventory list item can again be another component. Because of that, we can have this added functionality created within the inventory list item component. As you can see that all of these functionalities are embedded in each individual subcomponents, and that way we can separate all of the states handlings, the events handlings inside each subcomponents, individual subcomponents, so that when we look at each component, each one is self-contained and much cleaner, comparing with putting all of the functionalities into one page component. Right? So in this course, we are going to break down things as much as possible. Because of that, we are also going to talk about how to communicate between the components. Because the fact that when we break down a page into multiple components, we will need to have the ability to communicate between the components, like passing parameters or providing a callback, which I'm going to cover in later videos. In this video, we're going to start implementing this inventory list.razor, this page component. And the mockup of this page is right here. However, I don't want to implement everything inside this page component, as the previous video indicates that we want to break a big component into smaller ones. So in this video, let's focus on this part of the page. Okay, this is the inventory list page component. And let's go ahead and do that. So let's jump into Visual Studio right here. And let's create a controls folder. So we have a pages folder, and we can have a controls folder. A controls folder basically contains all of the reusable components that can be reused in different pages. And our inventory list component should belong to the controls folder. Then inside here, I can right click on the folder and create a new Razor component. And I'm going to, this time, keep the component suffix, because this time I'm creating a reusable component, and I'm going to call it inventory list component, and click on the add button. So because this is a reusable component, it's going to show up in other page component. Therefore, I don't want to have a title. I can remove this. And guess what's going to be displayed in here? It's just that list, right? And we implemented that in our home page, although it looks completely different from the mockup. But we can at least copy and paste the code over there to start with. Let's copy everything. Let's copy this and paste it in this one here. And it's just that we don't need the page title. We can remove this. We need use case to be injected in order to populate the inventory variable here with data when the component is initialized. It is just that we are not going to use an order list anymore, because we want to implement this type of list right here. And this is a HTML table. So let's go ahead and create the HTML table here. So let's keep the original code over here, and below that, we're going to create the HTML table. So we're going to say table, and class is table. This is a bootstrap class. And we're going to say t-head. Okay. So I just want to mention the bootstrap class. This is by default included in our application here. So if we go to the www root folder, this is the folder where we keep our static resources like CSS files, images, JavaScript. So we have this bootstrap folder over here, and we have this bootstrap.min.css. This is by default included in the root component, which is this app component over here. You can see that we are referencing the Bootstrap style sheets over here. So we can apply Bootstrap classes on our HTML elements. So this is not a Bootstrap course. I'm just using the Bootstrap classes directly in my HTML. If you need more information, you can learn it from Bootstrap website. It's actually very easy to use. So just for a table, you use the table class, and you're going to see that it makes a big difference. And here, within the T hat, I'm going to have a table row here, and we're going to have table header for each cell. And we're going to display name. We're going to display quantity of the inventory, and we're going to display the price of the inventory. And last but not least, we're going to have an empty column. This empty column is for the edit button, but it's not in the header. Now, after we complete the T hat, we're going to add a T body. Right? T body stands for table body. For T body, this is where we are going to use the loop. Right? We're going to loop through the inventories and create the table rows. So I'm going to copy this over here. Now, instead of using the LI element, we're going to use the TR element. Okay, so let's delete this. So TR element, and each column will correspond to the table header here. So I'm going to have TD element, and we're going to use implicit razor syntax to display inventory name. And next one, again, we're going to use implicit razor syntax to display the quantity. And next one is the price. And I'm going to say price dot toString. I'm going to format that to currency format. Last but not least, we are going to display the edit button. So it is going to be a button, and the type is a button, and the Bootstrap class. So let's format that a little better. Let's have each attribute occupy each line. So we have the class here, we have btn and btn-light. So this is also Bootstrap classes. And here I want to give it a name. So this is added. Now we have finished creating our components, and it's time for us to use this component in our page component. We have created our inventory list page component. We haven't implemented yet, so we can directly use our inventory list component here, and all of a sudden you're going to see data. Okay, so I entered a couple of line break here, and then we can use our inventory list component. How do I use component? Well, once you create a reusable component, you can use it in your page component, just like you are writing HTML. So we can say inventory. You can see this IntelliSense shows us the inventory list component. But if you do it this way, you have a very long name of the component because the first part is the namespace. So let's cut this out. And remember, there is a place where we can centralize the namespace, and that's the _imports.razor file. Let's go over here and paste it over here, and let's do add using. So when we do it here, we know that the controls folder will in the future contain many different reusable components. Therefore, it makes sense to centralize it in the _imports.razor file. Now, when I go back, this color already changed. It means that it recognizes where this component comes from. And in the future, when you add more components under the controls folder, you don't have to see the log name over here that has the namespace. You don't have to import the namespace on the page level. You can just directly reference all of the components under the controls folder. Okay, now that we have this inventory list component direct added over here, we can give it a try. So let's run our application, and let's go to our inventory list page component, and you can see that we have a beautiful HTML table displayed right here with our edit button right here on the right hand side. It is just that we forgot to delete this n order list. So let's go back and let's go to inventory list component, and let's delete this n order list. This will fix our problem. So rerun the application, and now the n order list is gone, and we have our inventory list beautifully displayed right here using Bootstrap class. So in this video, you'll learn that you can create reusable components. You can put it under controls folder. You can name the folder something else. I recommend you have a dedicated folder for reusable components. You can even group them into different folders under the controls folder. It's up to you. In this course, I'm just going to put all of the reusable components directly under the controls folder. But if you have too many, you want to group them logically, it's really up to you. It's just that you need to reference that from reference namespace from the _imports.razor, and then you can use it in your page component. You don't have to use it in your page component. You can use it in other reusable components. You can even use it in your own component to recursively create something, right? For example, if you want to create a tree view component, then you want to reference yourself. But that's an advanced topic. I'm not going to cover it in this video. So in this video, you learn to create the reusable component. You learn to reference the reusable component. And that's everything I want to talk about in this video. I will see you in the next one. In the previous video, we have implemented this component, right? This inventory list component, and we're using that in this inventory list page component. However, this is actually a pretty big component right here. If we go to the implementation of this page component, you can see that we have a lot of stuff going on with relatively simple requirement. So therefore, we need to follow our best practice and break this even further into smaller components. And one of the ways that we mentioned last time is that we need to break each one of this into a component, and we're going to call it inventory list item component. You can call it anything. And here I'm just going to call it inventory list item component. So I'm going to go over here, go to controls folder, and I'm going to go to here to create a new reader component, and I'm going to call it inventory list item component. Now, because I have this, well, let's first of all delete this. We don't need it. Because we have already implemented inventory list component and it contains everything, we're basically just extracting the list item component, right? The inventory list item component from this component. So what we can do is identify the part that we want to extract. So which part do we want to extract? Looping through this inventories is the work of the list component, right? The list variable has to be contained within the list component. That cannot go wrong. You can't do anything else. Each component should follow the single responsibility principle. So it does its own thing. That's good for maintenance. That's good for scalability. And that's good architecture. So the list component is responsible to do its own thing, which is to keep this inventory list variable, load it, and display it. So this looping should be the work of the list component. However, each one of these TRs is not part of the list. It's the list item. So therefore, what we want to extract is this TR element here. So we're going to cut this, and we're going to go to the list item component, and we're going to paste it over here. So now you can see that we have this red squiggly line, which means that Visual Studio is complaining that we haven't defined this inventory. Like, why do you use it right away? So we don't have anything in here. How do we define it? How do we load information for the inventory? Well, that's where we mentioned in the single page application best practice, because we're breaking down bigger components to smaller ones, therefore we need to be able to communicate between the parent and the child components. Now we are breaking down this list component into two components. So therefore, this list component is the parent component, and the list item component is the child component. We need to be able to enable the communication between the two. So the parent component in this case needs to tell the child component that this inventory is the one that it needs. So how do we do that? We're going to do that through component parameters. So let's go to the list item component and create component parameter. And for that, first of all, we need to create a public property. And this public property is of the type that you want to pass in. So what are we trying to pass in? We're trying to pass in the inventory from the parent component. Therefore, the type over here is inventory. And here we can call it just like this, and it's going to solve our problem. But this is not good, right? C#, you always want to use capitalized variable for public properties. So we can give it the same name. We can say inventory, and because of this green squiggly line here, we want to add a question mark over here. So now that we changed the variable name, let's replace this with our new variable here. And now you can see we have green squiggly line, and this is trying to say that this is possibly null. So therefore, we want to use the if statement to make sure it's not null. So only when it's not null, we're going to display the HTML. So we're going to say this.inventory is not null. So when it's not null, we're going to put this HTML inside it in order to display it. So now you can see the green squiggly line is not there, and there's no red squiggly line. Now we can use this child component inside the parent component. So let's go inside here and go under the for each. And we're going to repeatedly render the inventory list item component. So I'm going to say inventory list item component, and that's it. Well, are we sure that's it? No. The inventory list component has a public parameter, and that has to be passed in. Then how do we pass it? Well, remember, see this HTML? It has attributes. The component that we're writing over here, it looks like just HTML element, right? And the way to pass in parameter is the same as regular HTML. We just use attribute. Okay, so here we are going to access the parameter that we just created. For some reason, we just doesn't see the parameter that we just created. So let's go back and make sure that we created property. No, this is not enough. A public property is not enough to make this a component parameter. In order to make a public property to behave like a component parameter, we have to use a C# attribute. And C# attribute has a parameters attribute here. And once we do that, let's go back to the parent component. And now let's do space. And immediately the first one you see is the inventory parameter. And what we need to do is just pass in this inventory over here. Keep your mouse highlighted just to make sure that this is considered as a C#, not just a string, right? You can see that it's considered as a C#. It knows that. And I believe that's everything we need to do over here. Let's give it a try. Just make sure it works the same way as before. Now it's building, and build succeeded. And let's go to our inventories page again. And we can see that our inventory list is still being displayed as before. That means our extraction over here works perfectly. But this time you can see that it decreased our amount of HTML. And later when we extract components, you will find that if the extracted component itself contains some logic, in this case it doesn't, then you will see that it will significantly increase the amount of logic as well. Okay? So that's the beauty of extracting components into breaking down big components into smaller components and follow the single responsibility principle. And that's everything I want to cover in this video. Please let me know. If not, I will see you in the next one.